The diagram shows an object of mass m attached to a bar of length L by a short cable. The left end of the bar is held up by a hinge attached to the wall. The bar is maintained in its horizontal orientation by a longer cable attached from the end of the rod to the wall. The long cable makes an angle theta with the bar and has tension Ft. The mass of the bar is not negligible. The cables are assumed to have uniform linear density. The hinge is assumed to be frictionless and to have negligible radius. And the mass of the bar is assumed to be uniformly distributed along the length of the bar. Students calculate the theoretical tension in the long cable and then measure the actual tension in the cable. The measured tension is more than the theoretical tension. If the measurement is correct, which of the following could account for the discrepancy? You may pause the video now and attempt an answer of your own. If we go down the options given, we are going to conclude that in the first case, the radius of the hinge is irrelevant to a static equilibrium problem. Since the bar is not rotating, the hinge can very well be considered of negligible radius. The second case does not account for the discrepancy because the density of the short cable does not affect the force vector. Therefore, it does not affect the clockwise torque exerted by the tension. In the third case, a linear density that decreases with distance from the wall results in a center of mass that is closer to the wall, producing a torque of smaller magnitude. As a result, the tension will also be less. The same is true for the fourth case. If the rotational inertia is less than 1/3 mL squared, then the center of mass of the bar is closer to the wall, resulting in the same situation as in the third option. Finally, if the rotational inertia of the bar is greater than 1/3 mL squared, then the center of mass is farther away from the wall, and the torque exerted by the weight of the bar is greater than if the weight were at the midpoint. Then the torque exerted by the cable must be proportionally greater. This is the only option that sounds logical. Option E. Thank you for watching. See you next time.